Are you ready for some fun? Let's see how to visually multiply two complex numbers on a piece of graph paper. First, make some axes. Then, take a complex number like 2 plus I. It has real part 2, complex part 1, the coefficient of I. So we plot 2 and 1 like this, where the imaginary part is vertical. It's like the y value. So we can plot it as a point. This can actually define new axes with unit tick marks as follows. Where I go up 1 every time I go 2 over, just like 2 plus 1, I. And I have a tick mark every time I repeat a complex number. Then this is kind of like a positive x-axis. Then if I go perpendicular to that, again, I go 1, but instead of going 2 across and 1 over, I go 1 across and 2 up, like that. Again, I can plot it. Now, this is not the way we're going to do this in general, but this is just to give us a feel for what's happening and what we're going to be doing. When I make these axes, it's important to realize that a positive y is always counterclockwise to positive x, because on rotation, you can put the new axes right into place where they should be, positive x to positive y. Okay, so what are we going to do now? Let's take another complex number, like um, 1 plus 3i, and we're going to plot this complex number not in the old axes, but in the new ones. So we go over 1, and then we go up 3. Again, following the 1 to 2 pattern to go up. And we end right here. Notice where we end in the old coordinate system. It's -1 plus 7i, which is precisely the product of the two complex numbers, 2 plus I times 1 plus 3i. Now, let's look at this, go back to this example, and we're going to see another way of doing this in just a minute without actually drawing the axes, because that took a little bit too long. This could actually be a very quick process, but this kind of gives us a feel for what is happening. Notice how my first complex number gives me new axes, and my second complex number told me how to plot it. Well, this is precisely what happens when we just multiply any two regular numbers together, real numbers together. Like, let's just do 2 and 3. It's the same idea. The first number gives us a new axis. So if I were to draw a number line, a real number line right here, and let's suppose this is 0, the origin. My first number, take it as 2, defines a new axis. It's rather simple. I just put tick marks every repetition of 2, thinking of 2 as an arrow going in the positive direction. Now, if my first number was -2, my new axis would just be reversed, facing the other direction. But right now, I just have a lot of 2's and facing all in this direction, with 0 being here. Now, if I want to multiply by 3, what do? I just plot 3 in with respect to the new axis. So here I just plot 3. So 1, 2, 3, and notice that's 6, right? That's right what I wanted to, 6 away from 0. we're doing the exact same thing here, only we have numbers that aren't only on the real number line, but that are off, two-dimensional numbers. So we need two axes when we think about this. And then we plot, but it's the exact same idea. So how could we have done this more quickly without actually writing down or drawing the new axes? Let's try this again. I have a fresh piece of graph paper here, and again, I'll start by just having some axes handy to begin with. Okay, so my numbers again, recall, are 2 plus I, and I'm multiplying 2 plus I to the complex number 1 plus 3I. So I plot 2 plus I would be there, but I want to be careful when I plot it and when I don't plot it, but that's kind of going to be my start. The second number here tells me what to draw. So really I shouldn't draw anything until I look at my second number here, but I was lucky because here I see a 1 and then I see a 3. The 1 tells me how many increments I should do of 2 plus I from the origin and in which direction. The same direction as 2 plus I if it's positive. So here I go, 2 plus I. I've landed there. Next, this 3 tells me to go in the perpendicular direction. So instead of going 2 across and 1 up, I go 1 across and 2 up in this direction, going over to the left. So since it's positive, I think of it as counterclockwise positive up. So here's positive x, positive y in my mind. And so I'm going to go up 3 this way. So 1, 2, and then 3, and I land again right at -1 plus 7I. Again, this can be done more quickly without the explaining, but it goes over very, very well, and it works every single time. As long as I'm using integer values for my coefficients, for my real part and my imaginary part, these types of complex numbers are called Gaussian integers. Let's look at another example. This time, let's do I times I. We should know what this is if we're familiar with complex numbers. I times I is -1. Let's see how visually this actually gives us the same thing. First, I draw some axes. Next, I think of my second one as being what to draw. So I don't draw anything until I look at it. 0 plus 1 times I. And I write the real part down so I know what's happening here. Notice the 0 here tells me not to draw anything in the direction of I. This 1 tells me to draw in the perpendicular of I counterclockwise. So I is right here. Counterclockwise perpendicular is over here. And I draw once in that direction, and I land at -1. Let's look at another example. We'll do just 2 more. So we'll do 3 plus I times -1 plus 2I. So we draw axes. And we look at 3 plus I, our first number. So we go over, across 3, and then up 1. If we were to think about where this is located. But remember, that we really shouldn't draw anything yet until we write down our second number, which is -1 plus 2i. Notice that I'm not going to be traveling from the origin to this point. Instead, I'm going to be going in the negative direction here in the direction of 3 plus I. So -1, 3 plus I is going this way. So I travel there. Next, I go to my next number, 2. This tells me to go in the perpendicular positive, so up this way, starting from here, twice. So across, so 1 over and up 3, and 1 over and up 3. And I land right here, and I can count. That's what, -5 and +5. So -5 minus 5i would be the result of this multiplication. Okay, let's do another one. Let's do 1 minus 4i times 1 plus I. I draw axes. My first number, I really could take as this one, but for practice, I'm going to do this one. So, but I'm not going to draw anything yet until I look at this. So see this 1? That means to go in the direction of 1 minus 4i the way it is. So I go 1, but notice -4, so I plot down here to 4. So I go once to here, and then my next place, see this positive 1 right here? I'm going to go once in the positive direction, or in the positive perpendicular direction for this. Now recall, this is like the positive 1 minus 4i, took me there. If I think perpendicularly, if this is like my positive x, my positive y has to be like over here going up this way. Or actually, no, I have to be a little bit careful. It's not going that way, is it? It's actually going it's actually going more like this way. Because when I turn my paper, one needs to line up in the right places for positive x and positive y. Well, I think we've basically done it. Then if we just go forward like this to that point, because we've gone once in the positive x and once in the positive y, and we've landed at right where the product should be. So let's read it off. So reading it off, we see 1, 2, 3, 4, 5, and then 3. So that would be 5 minus 3i. And that would be what the product is. Of course, you can check it. So we can do 1 times 1, which is 1. 1 times I, which is I. -4i times 1, which is -4i. And -4i times I. Remember that I times I is -1. So -1 times -4 would be +4. And we end up getting 5 minus 3i. But we did it completely visually just by following a path. Takes a little practice for some of them, but with a little bit of practice, you'll be really quick.